Welcome to Third Angle, where you find us following the wind of change to sustainable energy solutions. I'm your host, Paul Hames from industrial software company PTC. In this podcast, we share the moments where digital transforms physical and meet the brilliant minds behind some of the most innovative products around the world, each powered by PTC technology. With the planet facing a climate crisis, we all know that the future of energy production needs to be green. Playing a huge part in our energy future is wind power. And in 2022, wind supplied over 7% of the world's electricity. Vestas is a sustainable energy solutions provider with more than 40 years of experience in wind energy technology and wind turbines installed in 88 countries. The precision design of their wind turbines is crucial. Similar to how a Formula One car generates downforce, the wind turbine is designed to push the air around the blades in a way which increases their rotation and generates as much energy as possible. And the sheer size of a modern turbine blade is a feat of engineering, reaching over 115 meters for their largest offshore turbines. But bigger is not always better. To be truly sustainable, Vestas also needs to consider the environmental impact of its turbine's entire life cycle. Through their sustainability strategy and circularity roadmap, they're ensuring crucial components like glass fiber blades are recyclable, or that wind turbine towers can be made using low-emission steel. We sent our producer, Peter Norgard Mathiasen, to the Vestas headquarters in Denmark to meet Pedro Pastilla, the head of onshore product management, who tells us about the future of wind production.
So my name is Pedro Pastilla. I'm the head of onshore product management here in Vestas. We are in the central headquarters where our engineering is headquartered. One of three engineering centers that we have. The other one is in Porto and another one in Chennai in India. Here, basically, we come up, envision and design our wind turbines, and we define what's the future for the wind technology. So Vestas and the roots of this company has a lot to do with its character. Vestas was born 125 years ago as blacksmiths, making agricultural applications. But it wasn't until the 70s with the oil crisis that we've discovered that there was an opportunity to mitigate the oil prices by generating electricity from alternative sources. And from there, the whole birth and focus of Vestas as a wind turbine manufacturer came from. And there's always been that kind of problem-solving mindset to this organization, especially to the engineers in this building, of tackling the challenges that we see in the organization. So now we're moving into my favorite part of the building. Here you can see two things. One is scale models of a sample of the history of Vestas from the very beginnings. As a wind turbine manufacturer into our flagship turbines today. You can also see on the left-hand side, we have a life-scaled nacelle of an old turbine, which inside has a virtual reality center, which we use both to show customers how the inside of wind turbine looks like currently, but also the similar system is used to train our service technicians that go on the field when they need to familiarize themselves with how a turbine looks like. As we move across this row of turbines, you'll see that one of our first turbines had a 15-meter diameter. So it was roughly 7.5-meter blades. And you can see how small it was in the grand scheme of things. So over time, the best way that we found over the last 40 years to reduce the cost of energy and make wind energy one of the most competitive wind sources, if not the most in some cases, has been to grow the size of the rotor, to capture more wind and more energy from the wind. We went over the kind of the end of the century with turbines sitting at roughly 80 meters in diameter. And in the next 20 years, what we've seen has been a substantial growth that has taken us to our currently biggest onshore turbine, which is a V172, which means that the blades on that turbine are roughly 80 meters, so almost twice the size. It is quite a big sense of scale. And that leads to one of the most interesting challenges we have today, which is this growth that we see here spanning from the 70s, has been a strong enabler to us reducing the cost of energy and creating cheap renewable energy. But what we see looking into the future is also a level of scale in the industry that is orders of magnitude larger than what we've seen in the past. At the same time, one of the biggest challenges we see is that increasing size of turbines, while historically has been an advantage, is not so clear going forward. This is because, of course, the investments needed are huge to continue growing these turbines across all components. But at the same time, we have gone from facing what we call value chain challenges, so transport challenges. Every time you increase the size of turbines, there's different challenges to tackle. Of course, there's how we transport blades up a mountain, and we've developed very, very creative solutions for that where we can lift the blade. But the level of challenges we're seeing today is really infrastructural, size of harbors, size of ships. So it's grown to an order of magnitude where simply saying that we, from a technology point of view, can continuously grow it will not allow us or will not help us to the growth that we need to see to meet our climate targets. And that leads to then other really interesting technology challenges that we're facing as an industry, which is not so much how do we grow the size of turbines to be more efficient in capturing energy, but more around how do we increase their efficiency at their current size, but especially how do we industrialize them for the incredible growth that this industry needs to see and will see over the next years to scale up to meet our climate targets and the ambitions that we see for renewables. And also maintaining that level of competitiveness that today leads it to be one of the most competitive energy sources on the planet. And at the same time ensuring that we have kind of a stronger capacity to support grids and electricity systems so that people never lose electricity at their homes by having more renewable power in the grids. Over time, the wind turbines have evolved to be a three-bladed concept. Basically, the whole idea of the wind turbine is to catch as much energy from the wind as possible. Increasing the number of blades would somewhat add capacity to extract some wind energy, but at the same time would have a weight penalty that would contradict that energy extraction. So overall, what is really important is the area, because that defines to some extent how much energy you can extract from the wind. That doesn't mean that we don't have substantial technology innovations when it comes to materials, when it comes to smarter turbines, when it comes to design optimization. But the overall concept of a three-blade turbine is here to stay, I believe. So the typical wind turbine blade, like the one you see here, and this one is roughly 50 meters, it is built of glass fiber, and it has a number of reinforcements on the inside to ensure its structural integrity over the lifetime of operation of a turbine, which typically ranges from 20 to 30 years, sometimes often beyond that. They are built structurally in a way that is relatively similar to aircraft construction technologies. So they have reinforcements internally, and then of course there's a shell made of glass fiber that covers the blade, and often with carbon fiber reinforcement. The blades are then bolted into what we call a hub, which is a rotating centerpiece that holds all three pieces of the blades and then connects that with the gearbox, which is then what connects with the generator and how we produce electricity. Over time and scale of wind industry, we have very quickly become one of the biggest world's consumers of carbon fiber and glass fiber, exactly because these turbines are growing in size. And it's quite interesting also how we focused on sustainability by establishing ways to recycle these blades, because glass fiber has historically been challenging to recycle. So a very important aspect for Vestas has been how do we ensure that these blades, from a sustainability perspective, can have a second life and can be redesigned and reutilized into other applications, but also potentially into redesigning and rebuilding new blades from the existing ones that are in the market right now. Another interesting aspect that you'll see here in this blade as it's sectioned is this wire that goes through it. So of course wind turbines have to operate over different environmental conditions. And of course one key consideration is that you have often storms with lightnings, and of course having a big blade sticking up in the sky is a huge way to attract, especially also as they are made of carbon fiber, which tends to conduct electricity quite well. So all our wind turbines are equipped with what we call a lightning protection system, which basically collects, as you saw those rods in the tip of the blade, it collects electricity should there be a lightning strike and drives it through the whole turbine into the ground to make sure that we minimize any damage that could come from that lightning hit on the blade, and that it doesn't trigger, of course, damage to the turbine. So you can see here it's quite a thick wire because the currents that they take are quite substantial. One key characteristic of wind turbine design is how we balance how fast the blades spin with, of course, the noise that they generate and the efficiency of their aerodynamic profiles. So the interesting aspect of this is, as you have wind turbines spinning, we have stabilized the tip speeds of these blades to be well below sonic wind speeds, because that would increase the noise substantially. So there is an element of stabilizing wind speeds as the wind turbines rotate, to ensure that we don't generate too much noise in the production, which is a key priority for the introduction of wind, especially as you go closer to people's homes. And it is a key design driver for how we come up with the turbines and how we define their operating modes. In many ways, from an aerodynamics perspective or a theoretical perspective, the way a wind profile works is very much the way a Formula One wing works to generate downforce, the way a blade profile here that you see this shape where you see that it's more rounded on one side and more concave on the other. That is designed to generate suction on one side and generate pressure on the other side. That basically pushes the blade. Of course, in an aircraft, you want that blade to be pushed upwards. In a race car, you want it to be pushed downwards. In a wind turbine, you want to increase the rotational torque of the wind turbine, which is inevitably is the energy that you convert into electricity. The physics principle is exactly the same. The wind speeds they are designed for, and of course the scale they are designed for is very different. The profiles would be very, very similar, and if you take these in isolation, we often use profiles that have been designed for NASA in wind turbines, and those profiles are also used in aviation, in aerospace. So the physics of it is relatively simple with all the complexities that come with aerodynamics and common across, but how you optimize for the specific case of wind capture is very specific and very particular and very different. So there's a lot of engineering work that has gone into this to differentiate what we have in a wind turbine over what you would see on a race car or on an aircraft. I come from a mountainous area in mainland Portugal, where there has been a lot of wind development, and there's a wind farm very close to my parents' house, which is Vestas Turbines, and to me, it's just a natural evolution of the old windmills that we used to produce flour to make bread. We are now using the same concept to generate electricity. So there is a beautiful historical accuracy. And I think on that, there's also an interesting anecdote, especially in Portugal, which I know best. When you drive around areas which have a huge wind turbine electricity production, you will often see that the areas where they're positioned are peppered with old windmills. So there's an interesting aspect to that wisdom that the people of a few centuries ago were able to detect strong wind resource areas and develop their own kind of local applications, where now we have advanced algorithms and we're considering machine learning and AI to continue that prediction. But there's a lot of element and respect for the wisdom that came from the people before that were able to put the old school windmills in the same locations that we now identify as optimal through advanced algorithms to install renewable energy wind farms. And of course, I think also speaking about the maintenance of these turbines, as the industry grows, it's one of the largest employment areas. And another big challenge that Vestas sees is that, and the industry will face over time, is that, of course, these turbines require maintenance. And it's a big focus for us also to make them as maintenance-free as possible. But like any other thing that runs for 20 plus years, there is predictive maintenance that needs to happen. There's corrective maintenance that needs to happen. And there's a huge workforce of technicians that support this operation that are spread globally in all kinds of locations. And over time, that workforce will continue. So the demands for employment of qualified service technicians will continue growing. And so there's a huge opportunity for wind also as an employment area, which is hugely diverse because, of course, we operate turbines in all countries, or in over 80 countries, and they require local deployment of qualified technicians that are ready and prepared to maintain these turbines. So this revolution that we will see in renewables also carries a huge opportunity for differentiated and qualified employment across many, many countries. So another interesting aspect is that, as you see here, these turbines can range from 70, 80 meters these days to up to 175 meters is our current largest tower. But it takes several minutes, often up to half an hour, to take the elevator all the way up, as we are talking about a significant height. And it does feel like you're going in quite a journey as you head up, and of course everything starts moving a little bit as you're up in those heights. So it's quite an exciting journey to sit atop one of these towers that often sit on top of mountains and ridges. And you really feel like you're on top of the world when you get this. It's quite exhilarating to see.
That was Pedro Pastilla from Vestas. The design of the turbine needs to take into account a number of factors, including aerodynamics, aesthetics, and efficiency. A digital thread is a really important part of this. And it's time to meet our expert, Mark Lobo, General Manager of Product Lifecycle Management at PTC. Mark, what is the role of enterprise-wide PLM in supporting companies like Vestas who are facing challenges of cost, logistics, and the pace of innovation? And Vestas is highly focused on sustainability. How can you help companies like Vestas create more sustainable turbines?
Vestas has very ambitious targets for sustainability. You heard from them straight up front. The reality is that it's not just Vestas. Sustainability is an important topic for PTC and for all our customers around the globe. So let me give you and others a quick overview of the areas we are looking into. The first one is choosing the right material upfront is super important, as it affects how you account for dematerialization during the product design, and then at the end of the life of the product, with the amount of material content companies have to recycle. Second, let's talk about the factory. We are helping companies make better decisions about the manufacturing processes to be used, where some of them might have lower electricity consumption, as a simple example. Even before a product is out in the field, we can also simulate for component and product longevity and validate that with real-world data when the product is actually operating and being serviced in the field. So these are quick examples from design to manufacturing to service. The goal is that sustainability becomes something that our customers can configure when they offer their products to their consumers. And this is where PLM really comes into the picture. PLM can help ensure that when companies are designing products, sustainability is a clear and conscious choice. From the materials designers are selecting to how you are configuring your products in terms of the reuse of components, to which suppliers you are choosing, now designers are able to pick something that does not compromise the integrity of the product, does not blow out the cost, which is very important, but at the same time is environmental friendly.
Huge thanks to Pedro Pastilla for showing us around the Vestas headquarters in Aarhus, Denmark. Please rate, review, and subscribe to our bi-weekly Third Angle episodes wherever you listen to your podcasts, and follow PTC on LinkedIn and X for future episodes. This is an 1860 production for PTC. Executive producer is Jackie Cook. Recording by Peter Norgard Mathiasen, sound design and editing by Clarissa Maycock, and music by Rowan Bishop.